Hey everybody, welcome back to Daily Math Concepts. If you're just joining this channel for the first time, come on, just like this video and share it, subscribe to the channel. Let's get into some vectors. We're looking at some vectors today, and we want to make sure that we understand how a CSEC vector question may look. In the diagram below, the coordinates of P and Q are 2, 4, 8, 0, respectively. Uh, put it over. In the diagram below, the coordinates of P and Q are 2, 4, and 8, 2, respectively. The line segment joining the origin 0, 0 to the point P may be written as OP. All right, so we're seeing the diagram here. So here's the first question. The first question says, what term is used to describe OP? Well, OP is simply a position vector. That is the term. It's a position vector, and I mean, it's 2 marks for this. It's a position vector. OP is a position vector. Let's see what they want now. It says, write each of the following in the form AB. It's like saying X, Y, same thing. OP. Now, remember, if you're given the coordinate of a point in a position vector, you definitely would have the position vector with those same coordinates. So 2, 4 is for P. That means from O to P, it's basically 2, 4. It's the same coordinate, but you put it in a vector form, 2, 4, right? OQ, take a look at OQ. So OQ has to do with the point Q from O. We're going to have to turn it in a vector form. So it's a column vector, 8, 2. Right, so we have that. So those are the 2 marks we pick up very quick, very easily. Now they want us to do PQ. Now they want us to move from P to Q. So let us take a look. We want to find the PQ. PQ. Now remember that OP, look at the arrow, is 2, 4. And we also have OQ, which is 8, 2. So if I'm going to find PQ, then definitely you could take a look that we're going to be walking from P to O, and then we're going to leave O and just go straight to Q. And then you would have seen where we would have completed this PQ going that way. And that's what we really want right now. So basically, the idea is that we're going to be moving from P to O plus O and landed at Q. If you take a look at the movements, we're moving from P, we're landing at Q. This is my start, this is my end. The common ground is always in the middle. Let us now write these properly. PO, it's going to be the inverse of this because the direction would have changed. This is OP, but I need PO. So we're going to change the signs of the coordinate of the components. So it's going to be -2, -4. That's PO. Plus OQ. And OQ will be as is, 8, 2. So we have 8, 2. So basically what we're doing here, we're adding matrices. So it's -2 plus 8, -4 plus 2. And then we just finalize this. We're looking at 6 with a -2. And this is the vector PQ. Remember, do not leave your arrows off. It's very important that we have the arrows on. So that's PQ. So we would have answered PQ right here. It is 6 and -2 right there. And that's the 2 marks. Now, as we go further, we're now asked, when we're given this situation, it says, given that OP is equal to RQ. Now, we want to make sure that we understand this. OP is equal to RQ. Let us write this information. In other words, then, I've been given a second piece of information. I was just given RQ. I was told that RQ is equal to OP. OP is 2, 4. So that means this is also 2, 4, right? So we just got that. RQ is the same thing as OP, right? So we got that. Now, determine the coordinates of R. Now, we want to find the coordinates of R. This is what we want to understand. Based on the position vector system, I can find the coordinate of R if I have OR. Because in a position vector system, the coordinate of R can be written in a vector format, position vector format as OR. So I could go from A to B. I could go vice versa. I should say we could flip it. So what I need to do is to find OR, and then I write the coordinate of the point R. Now let us look at it. We want to find OR in this question. So this is what we're aiming at, OR. Now, if we're going to find OR, we need some connection. I need something with R in it and something with Q in it, all right? So we're looking at RQ, then OQ is a perfect match. So we could see, you could see, look at this. This is OR here. Common ground is Q. So definitely I could put that together. Let me write back what my OQ is. We got that very early. It's 2, 8. So basically then, OR is to move from O to Q, and then we move from Q, and then we go to R. And when that is done, we would have captured OR. So basically, OQ will be as is. It is 2, 8. This is this. It's the same direction and everything. Plus QR. Remember now, I got RQ, but I need QR. So it's the inverse. So it means then my positive 2 becomes my negative 2. My positive 4 here becomes my negative 4. So with that said, all we're going to do is to add our vectors. Basically, 8 plus negative 2. Let me write it. 8 plus negative 2, and then 2 plus negative 4. Let's just finalize. 6, negative 2. So we have just wrote OR, and OR is 6, negative 2. Remember that we were asked to find the coordinate of R, and this is 6, negative 2. All right, good. Now, the question says here, state the type of quadrilateral that we have here for. Now, let us look at what we're dealing with. We are dealing with O, P, Q, R. All right, let me just quickly draw this. All right, so we have something like this, right? All right, don't watch my drawing. Now, remember, we have a few things. We have these, we had those, we have these. These are what we got. We have these. Now, if I'm going to determine what kind of quadrilateral, I need to look at each side that I have, like each vector. For example, we need to compare these. Look to see what I have. I'm going to do some quick comparison. So I'm just going to drop these on. I'm going to drop these on, and then we look at it. So let us just drop them on. OP was actually 2, 4. Right? We have OP as 2, 4. RQ was the same. It's 2, 4. We found PQ to be 6, negative 2. Let me write that a little better. So moving from P to Q, we got 6, negative 2. And we are OR, we found that to be 6, negative 2 as well. Basically, when we observe this, we are noticing that opposite sides of this quadrilateral, they're equal and they're parallel too. Now, how do we know that they're parallel? For example, if I should take OP, and if I multiply OP by 1, I'm going to get RQ. So as you could see, If I use 1 to multiply by OP, I get RQ. Also, if I use 1 to multiply by PQ, I ended up with OR. So we're noticing parallelism here. So opposite sides are parallel because one is a factor of another. So with this, we know that the opposite sides are parallel. And secondly, we are looking at the same numbers too. For example, so opposite sides are parallel. That's 1. All right. So I'm thinking parallelogram. But then I need to just tighten up one thing. If I should take the size or what we'll call the magnitude of OP, it's going to equal to the magnitude of RQ. Also, if I should take the magnitude of PQ, it is going to equal to the magnitude of OR. Opposite sides are equal and parallel. This, my friend, is a parallelogram. So with a parallelogram, opposite sides are parallel and they're equal in terms of size. And that is what you would have done to collect those marks with your justification. Let us look at another vector question. So the question says, in the parallelogram OABCD, OA is parallel to DC. We're seeing those notification, parallelism. AB is parallel to OD. OD is equal to 2AB and OA is equal to 2DC. OA is equal to small a and AB is equal to small b. You're seeing them on it. Now, I'm going to finish labeling because I was told that OD is equal to 2 times AB. In other words, if I multiply this by 2, I'm going to get this side. And since this side was B, then this side has to be 2B because it is 2 times as big. That's what that says. Another thing here is that we were told that OA is 2 times BC. In other words, if I multiply DC by 2, I'm going to get this. Or if I half OA, I'm going to get DC. So OA, which is this, is A. So I'm going to half this to come here. So basically, based on the information, DC is a half A. So one of the things that you want to do is to label these sides nicely so that the questions you can easily just flow. Let's see the first question. So we have our diagram. I'm going to label it over here to be half A. So I'm going to put on my label here. This is 2B and this side here is a half A. Now let us get into the first question. The first question says, find in terms of A and B in its simplest form, AD. So we want to move from A to B. Let's take a look. Just drop a line. We could see our AD. AD is right here. This is my AD coming this way, right? So AD is coming this way. So my R, as you could see, coming this way. Now, we're going to just take a quick trip. I want to move from A. I want to end at D. There is no road here. So normally whenever they give you that vector, there is no road leading to that path that you want to go. So you're going to have to find some road around it. For example, the triangular law suggests that I could move from A to O and then move from O and ended at D. And I would have accomplished this distance, that vector. So all we're going to do is to apply the triangular law. So here it is. So the first question, we're looking at finding AD, and AD is to move from A to O, and then I'm going to pick up from O and go to D. Now, pay attention to the arrows that we're looking at. So you do notice that this arrow is going that way, but I don't want OA. I need AO because I'm coming this way. So it means then it's the inverse of my A. So it's the negative A that we're using. And then I'm going to take OD as is, which is plus 2B. And this is finished. All right. It's just that some people like to put the positive first. So you can say 2B minus A. And you're good right there. You would have, that's the same thing. All right. So we captured, quickly we capture our AD. Let's take a look at the second question. Question 2, we want to find BC. Let's go for it. BC. So for the second question, we need to find our BC here. So question 2 is saying, can you find BC? Now let's take a look. This is BC right here. This is what we want. So in other words, I'm just going to point to show the arrow. I'm coming this way. All right, BC. Coming BC. That's where I'm going. Now, we have a few options here, but I'm going to take the shortest way out. We can do this, right? So let me label this. Remember that this is actually minus A plus 2B. That's what that journey is. So I could move from B to A, and then I come from A to D, and then I go from D to C. So I would have moved from B to C. That's it. I agree that we could take other routes. For example, you could have gone here. You could have said, okay, A, B to A to O, O to D, D to C. And you would have gotten the same answer. All right, so it's up to you what you want to take. But I think I'm going to take the route here. All right, so I'm going to do this. It's a little bit less work, just a little bit less work. Boom. So let's set it up. I want to move, so I want to do BC. So it means then I'm going to move from B to A plus A to D plus D to C. Now, BA, notice the arrow. I'm going opposite to that. So it's going to be minus B. And then I'm going to be adding AD. AD is minus A plus 2B. And lastly, from D to C is a half A. Now, at this time, what you want to do is to collect your like terms. I have minus B, positive 2B. I also have minus A, positive half A. Now, let's group them. Minus B, positive 2B, minus A, positive half A. In simplification, negative B means negative 1B. We're going to end up with a positive B. Negative A plus half A. This is like negative 1 plus half. We're going to be left with negative half and then A. So basically, B, C is that, okay? Or if you want to put the negative half A first and then a positive B, you're good. If you want to do that, that's okay as well. So there it is. So this is just algebra, a vector where we just take our time and we fill that in. Let's take a look at the third question. Okay, question 3 is actually saying, hey, question 3 is saying here, the conclusion, right? State the conclusion can be drawn from AD and BC, okay? So let's take a look what BC is, all right? So AD, BC. So AD minus A plus 2B. So let me write them down. This is AD, it's minus A plus 2B, and BC is actually negative half A plus B. So these are my A, D, and BC. This means size or magnitude. Now, in order to express the relationship between their size, we have to see a scale factor that link them. So if you can show parallelism, it helps you to know what number you're going to use. For example, you can see for yourself here that if I multiply BC, if I multiply vector BC by 2, it is going to give me vector AD. Take a look. Or if you half AD, it gives you BC, whichever one you want to look at. So if I multiply BC, it's going to give me AD. So you can see that AD is actually a multiple of it. So AD is bigger. Now, because this is the scale factor that we use to prove the link in terms of their parallel, this scale factor is relative to how big AD is compared to BC. In other words, AD, the magnitude of AD is actually 2 times the magnitude of BC. In other words, if I multiply the size of BC by 2, I get what AD is. Or I could have wrote it this way, because you could flip it. Like if I take a half of the magnitude of AD, then I'll end up with the magnitude of BC. So either you could write and you're good. Thank you for watching Daily Maths Concept. And today we just look at vectors. Now, tomorrow or another day, we'll be looking at something else. Please subscribe to the channel. And trust me, these videos will help you in your upcoming CSEC exam. See you next time. Bye-bye.